Today is Monday, November 11th, 2024, and this is Spring Office Hours, Season 3, Episode 38, Test Containers with Oleg Šelajev. My name is Dan Vega, Spring Developer Advocate at Broadcom, joined by my good friend and colleague, DaShaun Carter. DaShaun, how you doing?
I am fantastic. It's a great day to be a Spring developer. And yeah, things are just going well. We're only 10 days away from Spring 3.4 being released.
Oh, I don't know if we've we've actually talked a little bit about that between us, but I don't think we've actually told anyone what we are planning on doing. Should we let that cat out of the bag?
Yeah, I absolutely think so. I think it's already scheduled and set up.
It's not in StreamYard, so we are not scheduled. We are not set up there.
well, we got to get that. We'll get that out.
Yeah.
But yeah, we're gonna have a special episode. With the announcement, with the release, we're gonna have a conversation with Phil Webb. And talk about all the new cool things that are coming in Spring.
Oh, that's going to be so fun. Cool. Well, that's going to be a lot of fun. That is next Thursday. That's right?
Yeah.
Wow.
Next Thursday.
Coming fast.
I'm going to be in San Francisco. I'm going to try to hook up so I can be in the room with Phil, and we'll make it
nice,
extra special. Yeah.
That'll be awesome. Cool. So, what have you been up to? I know you were out of town last week. We had a little bit of a special episode last week. We moved it from Monday to Wednesday to talk to Brian and Rawson about GraphQL. But you weren't here because you were off doing something fun.
I took my mom to Barcelona.
Oh wow, that's awesome.
And it was a good time. In between the event and all the things we had to do for the event and getting my running in, I still managed to squeeze in a bunch of really, really quality time with my mom, and it was
nice.
It was
Did you go see any? Did you see some cool things? Because there are some cool things to see there.
Yes, we saw a lot of the Gaudi. We did the bus tour, so we got to see a lot of cool stuff, and we had tons of food and wine, and it was
awesome.
Great. But the event itself was really special too. Barcelona, VMware Explorer at Barcelona. We had some really good announcements. We had some really great messaging coming from the general sessions. I got to do a really fun session with our good friend Oren Penso, and yeah, it was fun. It was fun. There was a lot of really great customer conversations, a lot of really good announcements. We got, I think, if you're into that kind of thing, the having a cloud, having an API where you can do things just like you would, that you expect from your big cloud providers. You can do a lot of those things now, and the API is great, and the consistency is great, and we've just kind of leveled up, and the way that they delivered it, it really made sense to me, and I'm excited for everybody.
Nice. All right, well, we have a special guest today, but before we get to that, I just want to let everybody know, again, we usually do this live stream every Monday from 1 to 2 Eastern. So if you're able to join us live and get those questions in. If you're here in the chat, let us know where you're joining us from, and please get those questions in. We're going to have a fun conversation about test containers with our friend Oleg today. But if you're not able to join us live, you can catch the replay on the Spring Developer YouTube channel. You can also go ahead and get this wherever you get your podcasts, usually the very next day. So if you are listening to us on a podcast, maybe you're taking us for a run or a nice little walk through a trail somewhere, do us a big favor. Go ahead and leave us a review. That would really help us out, get us in front of more folks. So thanks to everyone who's been supporting. The podcast numbers are through the roof, like from where they started.
Fantastic. And that's a big deal because our timing when we do the show isn't always the best for our friends on the other side of the ocean. And so a lot of them are really big fans of the podcast. And like I said, for those of you that are joining live, let us know where you're joining from, because my mom and dad like to see where everybody's joining from. That's always fun. And when you come to my house for dinner, if you leave hungry, that's your fault. Here, if you're here live, you're joining us, and you've got questions, get them in the chat. Ask your questions. Don't leave hungry.
All right. With that, I'm going to bring on our special guest, our very good friend, Oleg, who we just had a conversation with before the show started. And I promised him I wouldn't butcher his name. And I did. That's what I did. I did exactly what I told him I wouldn't do. Oleg, I'm sorry, my friend, but
Oleg
really
Šelajev.
Good to see you.
Did I say it right that time?
It's all right. It's great to be here. Thank you for inviting me. Thank you. uh, or listening to this.
Oh, I'm cutting out. The audio's cutting out.
Yep,
Oleg.
you kind of cut out. You were fine before. Now it's
Yeah.
like going in and out.
When you say you, do you mean me or do you
Yeah,
mean
you.
Yep,
Oleg.
that was you.
Now it's
Now you're
better.
good.
Okay, very good. I
All
just
right.
moved my mouse closer to the microphone as well.
All right. So Oleg, I see there your title, for those of us who are not on the live stream, says Developer Advocate at Docker. I almost forgot that before we got started today. You're with Docker now.
It's been almost a year.
It's been a while. So can you tell us a little bit about yourself, what you're doing at Docker, where kind of test containers fits into that?
Right, of course. So my journey, so I'm a developer advocate, so let's start there, right? It's my journey there started like almost a decade ago when after I switched my Java developer career into more marketing related position. And that was a long time ago. And since then, I've been at different companies for a few teams. I was doing quite a bit of GraalVM developer advocacy at Oracle Labs. And then a few years back, I joined the Test Containers team and Test Containers folks building and maintaining the libraries community and the cloud products for a startup called Atomic Jar. So now, last December, almost a year ago, as DaShaun mentioned, the startup was acquired by Docker, which is great because Test Containers, of course, has always been always had a dependency on Docker environments to be able to actually run and manage the containers. So I think it was a very strategic acquisition for both parties. Test Containers got the support and sort of the approved sign by a much larger Docker company and community. And of course, Docker bought an excellent team and spectacular technology.
Yeah.
Test Containers libraries are, of course, open source, right? So it's not going to change. It's going to continue being open source. There are people maintaining, and in general, Docker has quite a good history of open source support and development from Docker Engine to other projects. But so like that migration happened, right? So now I'm at the developer relations team at Docker, and there are a few folks there, and my area of expertise and focus and my interests are still test containers, of course, but it's more broader developer productivity. And recently also I'm dabbing into thinking and trying various AI related questions and trying to figure out approaches, mostly again from the application developer perspective. So less machine learning engineering background, but I do have some understanding how like DevOps process works and why we're doing DevOps rather than something else. And that's where my interest in AI is as well. How would applications look like when we're going to build them and have some components of them being sort of AI modules for whatever the implementation might be, right? Some AI components with them. So there is that. And Docker, of course, is like a startup. It is still a startup. Not everyone is on board with that. We're currently at approximately 600 people, and there's of course like quite a journey, right? Because Docker started maybe 10 years ago or around 10 years ago, and there was a lot of things that containers revolutionized for developers. And then eventually, currently Docker is very focused on developer productivity and the inner loop use cases. And we have a suite of tools and technologies helping with all tasks related to containers. There is, of course, Docker Desktop, which is your runtime for containers. And there are some cloud services improving your productivity in teams like Docker Build Cloud and Test Containers Cloud. And there's Docker Scout for security. And on the previous stream, we looked at a little application where all of those pieces came together within like one iteration of the development process. So this is the new Docker. A lot of folks sometimes still refer to it as in like, oh yeah, I run containers in production. Like, what can Docker do for me there? And the focus of the company currently is on improving lives of developers, which I think is great, because
I'm grateful for that.
Yeah, absolutely. Cool. So that's a little bit of a background on you. I think one place I want to start, because not everybody may be using test containers, more specifically for our community, for the Java and Spring folks. What is test containers, and more importantly, I like to start with, what problem does it solve? Because I don't like just learning something to learn something. Like, what problem is this going to solve for me?
Right. Absolutely. Test containers are open source libraries, and the approach is implemented in different languages. So it's not a Java-specific technology. Right. And the libraries are available in .NET, in Golang, well, in Java, of course, right? But in Node.js, in Python, and some other languages. So they give you the API. The libraries give you the API to control, manage the lifecycle, and configure containers programmatically from your code. This gives you a number of benefits, right? What you can do, because it's in your code, you can create the containers with necessary services from your application lifecycle code. It can be your application lifecycle creating the necessary dependencies for the application to run locally, like speeding up a database in a container. Or it could be your application tests, which is a more classic use case, and which is where we started initially, thus the name, test containers. So the code test containers allows you to create services in containers and say which technologies you want to run in them. And you can run any Docker images. So that means that you can run virtually any and every technology that exists, and you can spin it up directly from your application test code, which gives you as a developer, it gives you unique flexibility to create setups for your application to run as a normal full application using technologies that you're going to use in production. You can use your actual real version of Postgres that you're going to run. You can use your Apache Kafka cluster definition. You can spin up your Elasticsearch. You don't need to mock those external dependencies. You can use the actual real thing. And you can spin up your application. You can configure it dynamically, because all those services will be created for you, and the information where they're running is available at runtime. So you can configure your application to consume those and run the application without depending on the externally provided services. That makes your application self-contained, or your application tests, if you wish, self-contained, depending only on the source code, and thus repeatable, and also isolated from external artifacts. Yep. Right? So you can run the same setup anywhere where there is a Docker environment. You can run the same setup in CI. You can run the same setup locally on your development machine. I can run the same setup on my Windows machine, on my Mac. Everyone on the team, when they run tests, they're going to run the application the same way, with the same set of dependencies and exactly the same configured, say, database schema or data built into the things, right? And it's repeatable. Test containers takes extra care for cleaning up the environment after the run, so you can run tests again and again and again and not get the stale thing. Yeah. And it gives you the ultimate flexibility as a developer.
Yeah, and I think one of the things that I heard is that really got me excited about it is that programmatical interface to it, because we had Docker before, right? We had Docker Compose. We could set up some configuration, write a compose file, spin up something, but that's a very manual, tedious process, right? As you said, it's not as repeatable. This is very repeatable on my machine, on your machine, and testing and production, however we want to do it, is a very repeatable process. So I think that's one of the things that really stands out to me.
There are two, well, there are several benefits, right, over other ways to run Docker or Docker containers. For if you're running things manually, like for example, running like a database with Docker run something, which is the most basic usage of how to run a container, of course, programmatic setup will give you this repeatability, right? But even compared to Docker Compose definitions, Test Containers gives you two super important advantages. One, it's a flexible setup where you precisely control the lifecycle of things. The declarative Docker Compose, it's a little bit static in a way where you need to provide the configuration ahead of time, and it's a separate thing, right? So your application can find those services when it knows the URLs. They need to be stable. They need to be fixed. With test containers, you control the configuration dynamically, right? If I spin up a database and it spins up on a random host port, it doesn't matter because I have the value of that port as an integer, and I pass it to my configuration dynamically. When I spin up a Kubernetes cluster, I know that there is a kubeconfig YAML file. I know that it's giant and I don't want to look at it, but it's in a string, right? I don't deal with YAML. I deal with a string instance that contains that YAML, and I pass it to my Kubernetes client, for example, to make like operations on the cluster or run API. Right? I don't need to see that configuration. So there's a flexibility in that. There is a flexibility in the runtime. I can run operations at certain stages. I can create the database or run my Kafka cluster and then run some commands before relinquishing control back to the application tests. But I can create the setup that I need for the particular tests. I can break my database schema if I need to test some negative use case. I can do anything because it's in the code, and there are like hooks into every stage of control cycle. And then, so a flexibility. And then, of course, the crown jewel of that, the programmatic language definitions allow you for abstractions. And this is the beauty. The S containers comes with the whole ecosystem of modules, which are predefined, pre-configured abstractions, which are just the libraries in your language that you can plug in, and you get definitions how to run particular technologies. As an application developer, you don't need to know how to run stuff, right?
And I don't want to know. Yeah, those are things I don't want to know about.
Yeah, like do you need to know about like particular how to run Elasticsearch cluster, right?
No.
You might if you need to change a particular config for the test that requires this particular config, which the abstraction will allow you to do because it's just Java code. So you ultimately are in control of what's happening. But by default, you don't have to. And by default, also, they can give you the convenience API, which is another thing. I'd never thought about that before joining the team. But developers don't read documentation
until they need to.
Before things go wrong.
Yeah, right? Exactly.
It's so if it's not in your IDE, it might as well not exist. And like I'm the same, right? I will build incredibly complex systems from crutches and like dumb configuration and some dependencies between how stuff could work. I will do anything. It's just not to read the documentation. And then, but if there is an API call, my IDE will suggest it to me, and I will find it, and I will do the things the right way. So if my abstraction, if my technology offers a particular config, I can expose it as a method in my Java test containers library, and people will find it because they will type the dot and they will be like, I need something to deal with like admin password, right? And there will be a method like set admin password or something like this, right?
Yep. Simon says, it's not just developers. Nobody reads the documentation.
I don't know, Simon. Like my IKEA assembly is like step by step. I just, yeah. There is there is a bunch of advantages, and it's great. And the ecosystem of modules is probably my favorite because I really don't want to learn how to run Kafka in a container myself.
Right.
It has opened the door to so many things. Harpreet brings up like, hey, like we used all the different like in-memory database solutions to validate our DAOs and our access, but it wasn't always the same. We were having problems like, hey, when our custom queries might work against H2 and they don't run against the Oracle or the Postgres database, we were able to stop. We reduced the amount of work that we were doing, that I was doing, because I didn't want to have a big Confluence page to, hey, here's all the stuff you got to set up in order to run the test. I was using an in-memory database to kind of short circuit that. But also the configuring mocks. Like I don't have to do that anymore. We used to say, hey, we're going to mock it because you don't want to go and set up that other system. We don't want another Confluence page. So we came up with this idea of mocks. But test containers that makes it less code for me. It's less things I have to worry about. I can reduce the amount of mocks that I need to create because I can stand up the real implementations as a git clone run.
And we always talk about it, shifting left. I mean, you're catching these errors before you get to production. It's much easier and much financially easier to catch these issues before they get to production, right? Let's catch them on our local machine. Yeah. Another pro for me is, and I still am like baffled how this works, but these test containers are extremely fast, and to the point where like they have to be, right? Like if these are slow tests, I'm less likely to write them. But when these tests like give me immediate feedback and they're fast, I'm happy to run them. I think the first couple of times I ran a test using test containers, I was like, wow, I did not expect it to be that fast. Is there any magic going on underneath the hood to optimize those? Because they run really fast.
Right. Thank you. There are two answers to this, right? Is there any magic to this? No. So there is no magic, as in those are the normal containers that are being run using your normal Docker runtime that you are running. And it's now potentially now with test containers team being at Docker, we might figure out some performance optimizations specifically for the use cases for test containers, where, for example, containers go up and down quite a bit, right? Maybe now starting up containers could be a more important use case because there is a large community of people who are actually running this. But in a nutshell, those are normal containers, normal images that we run, normal containers. So there is no dark magic there, but there is a little bit of magic there, and that magic is, again, the ecosystem of modules, because certain technologies can be run in different modes. And normally when you get the Docker image, that is a production-oriented packaging, right? So when you run a database, you get your sort of sensible for production config. When I do Docker run Postgres 17, 16 latest, right? I get Postgres that it would run in production and it would not be bad, right? It might not be ideal for my use case, but it is sensible for production. Very often that is not what you want for testing.
Yep.
For example, for databases, you might not want to sync your writes to the file system immediately or batch them, or you can disable them for quite a bit longer. Because in production, if your database goes down and there are unwritten writes, you lose data, and that's a failure. Right? In testing, if your database crashes and you lose a couple of writes, you rerun the test. That's it. The stakes are lower, and so by default, we, for example, can disable the file system sync. So your database will be a little bit faster. Or your for example, your container configuration. Normally in production, when you run a container, it gets all the resources it can gobble, right? Because all the resources are for this container, because you limit resources on a different level. In development, usually you run multiple containers within the same Docker environment. So if they all gobble all the resources they have in that environment, they will have conflicts, right? So what test containers modules can do also limit the configuration, the default configuration, to not be as resource greedy. I think one of the modules that does that in a very cool way is the Red Panda test containers module. And Red Panda is, of course, the Kafka API compatible message broker. And I think they do the whole thing that Apache Kafka does. So there is a schema registry and other things, right? But so what the test containers module for Red Panda does, they enable the sort of development mode. So they have a sort of a main flag that turns on all those little optimizations. And then it's by default enabled in the test containers module. So when they release the new Red Panda release and there is something else that you can configure or tweak to have this performance improvements, they don't need to really change the flags or anything. You enable that with one flag. It's a separate testing in dev mode configuration. And that's what test containers runs by default. So you do get the best of both worlds by running the actual software, and you also can get some performance optimizations.
That's awesome. Great answer. Thank you.
Anytime.
I'm still giggling giddy about all of the modules. Like this ecosystem has grown so fast since the last time I remember perusing. There's so many things in here that I'm just like amazed at how massive this is.
Yeah.
And the other thing is that, I kind of mentioned it before, this idea is I can plug these things in, I can have them in my repository, configured as code. So I can bring anybody into my team and have them start working on it immediately. They don't have to worry about configuring and setting up and freeing up ports if they have another instance of that thing already running. It's already taken care of for us.
Yeah.
This is, very, very cool.
What's your favorite module, DaShaun? Putting you on the spot like that.
Well, I'm a big fan of Redis, and I'm not sure that there's a Redis module in here. I use Redis. Yes, there is. It's right here. Redis is my kind of go-to because for me, I get to do a lot of things with it. I can do the streaming and the JSON, and I can use Spring Data with it. So I can handle a lot of my different approaches with the same Redis.
You know that you can run it with the Redis stack image from Redis Labs, and then it comes with a little dashboard so you can look what's inside Redis as well. I think that would just run the same. You just need to swap the literal for the Docker image name, and you get tools as well.
Yep. If I'm not mistaken, I think that the Redis stack, all of those extras are now included in the Redis image.
Oh, maybe.
Yeah. It's things are moving. Things are moving. It's a great time to be a developer, and test containers is definitely something. One of the other pieces, I used to be, I wanted less things to configure in my repository. And a long time ago, before I think it was actually officially released, you introduced me to this test application where I can have my test containers running and stood up, but I can have my regular application consuming those test containers. And I didn't need a Docker Compose file. Having those implemented, and we get that now out of the initializer, but man, that is cool. I really like that approach.
This is the second part, right? So like it's where we outgrew the name of test containers a little bit, right? Because it's not just, there is nothing test specific in the API, right? Yeah, there are some additional APIs or methods for configuring lifecycle to tie it to your tests if you wish, but it's just code. You can literally have your Java main class and then just say like, oh, spin up my thing, which is actually interesting enough. If you do JBang starter, you can have a little Java program that you can consume, and it will spin up whatever ecosystem you need for yourself. But that's a secondary thing, right? Like it's just the main class was things. So you don't have to put it in your test lifecycle. You get put it into your application lifecycle and put it behind an if block saying like if development mode, spin up my dependencies if they don't exist. If production and the database is not configured, well, don't bother with test containers, just fail, because in production, I want my real database. So that can be like an if block in your main class, which would work. It's not the best solution for like a number of reasons, like your test libraries leaking into the main class path. But if you put that main class in your test class path, you have access to the main classes, you have access to your libraries. and you can just have that, right? So individually, a project could write 10 lines of code and have that experience as well. And of course, it is more complicated if you are on the framework side and you need to enable that for all the projects with all their different setups and try not to break existing ecosystem of like millions and millions projects. So that's a little bit harder. But luckily now we have the integration with Spring Boot, and that works out of the box.
Yeah, so I just for people who might be doing something similar to this and may not understand this, I've come across this many times. You go start a new project on the Spring Initializer, and you pick something like Docker Compose support and a Postgres database, right? So it creates a Compose file for you. When you start your application up, it will spin up that Postgres container for you. You have this database that you can use in development. But now I need to write a test for that. So I go write this test, and I think I'm connecting to that same container database, but in turn, you're actually not, right? So one approach to that is now I could bring in test container support and use test containers. So now I'm spinning up one container for my test and a different container for my development database, which is okay, right? This isn't okay. Like you said, it needs to be repeatable. So we're okay with the tests, right? Going against this throwaway container, right? So is that scenario okay where I have the Docker Compose for my development and the test containers for my test? Or do we like the approach that you were just kind of mentioning where test containers can be used at development time as well?
Well, we like test containers approach very much, right?
Yes.
There are a number of benefits to this. One, the very direct one, is that there is no duplication of config, right?
Mm-hmm.
It's just the same thing that you run for your tests, the same setup you use for your local application development, which mostly, in my experience, I use for running application and then going and clicking through that, sending some HTTP calls to it, and like just seeing what happens, right? Like I want to explore it a little bit. So I'm not doing anything complex there. It's very often is just some shallow checks to be like, oh yeah, this is it. Maybe tweaking some UI, maybe tweaking some particular messaging here and there, right? It's not something that, I don't know, like call me unprofessional. I will not probably write tests for every like string literal change, seeing that, oh, the message was a change or not, right? It's just seems a little bit over the top. But I would like to verify that. So I would run my application and actually see that, yeah, I changed the string and it propagates to where I need it to be. And then reusing the same setup it works fine. And it's also, there is nothing bad in using Compose setup. If you already have the Compose configuration and you use it for running it locally, your application locally, you might as well consume that from test containers config. There is a Docker Compose module, and you can ingest the Compose definition and create containers using test containers API from Compose. It will give you a little bit less flexibility, but it will bring it with the same sort of the same experience there. Yeah. And then after that, you can see whether you want to migrate. Either way, whether the setup works for you in the interim. As people say, there is nothing more permanent than temporary solutions. So maybe you're gonna stick with it until it's time to move to a new job or anything like this. But stuff works, right? It's just it gives you options. Having more options is a good thing. And depending on the particular use cases, you will find it that maybe static configuration of Compose is not something that you want, right? Very often, until a recent time at least, one advantage of Compose was static stable URLs to your dependencies. So you can connect your database viewer, for example, or other tools that you have locally on your machine, connect to containers.
True. And
then test containers exhibit this dynamic configuration, which is great to avoid collisions. But it's not so great, because if the ports you need to connect to are always jumping up and down.
Right.
It's a hassle to reconfigure the tools.
You would have to log something every time so you know exactly what dynamic port you're on to connect
Yeah.
like your database tools to.
So some people can prefer the static configuration. And
Yep.
until recently, that was sort of exactly that. Like you would log in a string and you would take that string and paste it somewhere. So at Atomic Jar, when we were developing this Testcontainers Desktop application, which is a small user space application, and it has some test container specific tooling, right? Because test containers runs normal containers, right? And test containers library sends like JSON commands to the Docker like daemon endpoint, right? So there is no magic. We're not doing anything like crazy with the runtime ourselves. We just send commands to the Docker daemon, like as any other tool running Docker would be. So, but test containers are a little bit different because we know that they're going to be going up and down, right? So we put stuff in Test Containers Desktop to simplify working with those setups. And one of those things is the thing we call services, which exactly about the stable URLs to the technologies in containers. When you run a database, for example, with test containers, it comes up and down all the time, right? It's ephemeral. It's a virtue, and you don't want to make it non-ephemeral in your code because you don't want to not forget to remove that like commented line or uncommented comment again, like before you're pushing the code, right? You want in the code, you want stuff that is good for CI, that is good for the whole team. And somehow locally, you want this setup that is good for you. So services in Test Containers Desktop allow you to connect to containers based on their technology. So you can say anything that runs Postgres with test containers, make that available on 5432 locally.
Yep. Nice.
So I can connect my database viewer or my IDE or any tooling to that local port. And then when there is a container backing that service implementation, when I have a test containers running Postgres, this desktop application will proxy it there, right? When it's the next run of my application and there's another container that is running Postgres on another port, my database viewer queries and the connection will be proxied there. So my tooling my local setup can be local, and my dynamic CI like appropriate setup or team appropriate setup would be in the code available for the team. So it was the best of both worlds, and now I have my tools connecting to containers in test containers, and I don't even remember sometimes that I configured them to be on those particular ports.
That's the big feature. I was going to ask the question, like, what's the reason why a Spring developer using test containers would want to install the Test Containers Desktop? And you just answered it. Because I use tools like Redis Insight. I use tools like a DB Viewer, and I have that then consistent service to attach to. That makes a lot of sense.
Yeah, you bookmark that stable URL, and that's your Redis Insight, or you connect your local things there.
This looks really cool. I haven't had a chance to download it, so I'm downloading Test Containers Desktop now, and I'll give it a spin. Thanks for sharing.
Yeah. If you're at it, like there's a plug, right? There's the ability to select Test Containers Cloud as the backend. So if you don't want to run containers locally because you don't have a local Docker runtime, or you want more resources to give to your containers for some speed up, or you want to avoid incompatibility between your Apple Silicon and some containers that don't have the ARM images, right? You can defer running containers to the cloud environment.
So that was one use case that we talked about earlier, was the ARM64. Like, hey, is there an image for this thing on ARM64, and I don't have it here, so I could run the x86 image up in Test Containers Cloud. Another really good use case that we kind of talked about later was GPUs. If I'm doing AI, if I'm running Olama, I can use Test Containers Cloud to validate things and get that GPU performance without having to go and buy a 4090, or I guess the 5090s are out now, right? So
yeah. So the GPU in Test Containers Cloud is not fully productized yet. So
it's coming soon.
It's you like email. There is like it works in the sense that there is a config that people can put in, and then it would sort of enable that, but it's not yet available globally, and it's not yet available as a product feature. So if you want that experience, if you are interested in that, like, contact us, please. Like, we'd love to talk to how to make that a production grade thing. And I'm sure there are a few questions to iron out, but it worked for my use case. It works perfectly.
That again, I don't have cloud money, I have Raspberry Pi money, but there are cases like if I want to validate something, I want to prove something without going out and forking over money for a GPU. That sounds like a great solution.
Well, it's a cloud service, so it's gonna be a paid service, right? Yeah. So like you have to, but you don't need to change your developer experience, and you also, it's a serverless, like, pay-as-you-go model. So you don't need to buy a GPU, right? You don't need to maybe rent a cloud GPU. You can just be like, oh, I'm running a Llama, I would like a GPU there. Let me have it.
Yep.
There is an Llama module actually in Test Containers modules as well. So like you can just get the Llama container with just 2 lines of code.
Nice.
Actually, that's another thing. One of the guides that's available, if you're running Llama and you're not on a 2 gigabit fiber line like Dan Vega, then you'll realize that sometimes it takes a little while to download those models. And one of the guides that's available on the Test Containers site on the Llama module is about you can save off these images. So you can download the models, and then you can save that model already downloaded, so you have a faster startup time. When you're doing that test loop, that inner loop, and you want to validate it, instead of having to download the models repeatedly, you can generate with test containers, you can generate an image that you can then use for your tests against a pinned model.
Yeah, that's actually a cool tidbit, right? So Test Containers has an opinionated API. What we think developers should be doing with containers, right? So, for example, we are trying to discourage things that would result in conflicts on the host machine, right? For example, setting container name, because you will not be able to create another container with the same name. So it's a little bit less pronounced in the API surface. But also, if you want to, you can drop down the level to get the Docker API directly, and then you can configure anything you want. You can configure the resources for the test containers for the particular container, saying like you get 1 gig of RAM and 1 CPU, or you can configure capabilities like enabling GPU support, but you also can run Docker commands. So this is what you want with specifically AI and the images. So images of inference servers, right? Like Llama CPP or a Llama or anything else. And you need a model, which is the weights, right? Sort of the brain that will actually process your requests. And then you need to combine them. So you can build a Docker image yourself, right? You can say like, here's my Docker file from a Llama, run this command, run that command, do this, do that. Or you can use somebody else's pre-built image. Mm-hmm. I think, for example, Langchain4j publishes some of the combinations that they use internally for testing. So you can use those. Or you can just do it directly from your test containers code. You can say like, if there is no model, pull the model, and after you're done pulling, commit this image to my local Docker cache as the particular image name. And then next time I want to instantiate a Llama with the same image, just check if there is a cache, because it's just code. You are literally being paid to do this all day, every day, right? So you can build whatever you want, and that's the beauty.
I think one thing that stands out for me too, we haven't really talked about it, but for Java developers, for Spring developers, this has gotten really easy to do in code. So there might have been some more code you had to write in the past, but now if you go to start.spring.io and you pick something like Postgres and test container support, you have all the dependencies you need. And then it's really just a few annotations now, right? Like we have the @testcontainers annotation that we place on the test class. And now we can just use container and service connection on that connection. So like create a new Postgres SQL container. And that's it. Before we had to like kind of jump some hoops, but now it's just a couple of annotations and you are good to go.
It was never that bad, right? So
No.
there are three.
But it was always I had to look up code and copy and paste it in because I could never remember it.
Yes, there are three main API sort of portions to that. One, you need to configure the service in the container, right? That means you need to expose the particular ports, or you need to put files into places and maybe put environment variables. That is one part what Test Containers API looks like. The other one is the life cycle, right? You need to control your containers. You need to start and stop them. And there is, of course, start and stop methods. But as you mentioned, there is also, for example, annotations that come from our JUnit 5 extension. So you can tie the life cycle of containers to the life cycle of your tests. And so this is the second part, the life cycle and the dependencies. And the third part is the convenience API to both configure things in containers. For example, running commands without specifying the this ugly Java running command syntax where you need to split a command with this strings, which is always awkward, and you forget one and then it mushes the arguments together and yells at you inexplicable something that you're like, what is happening? And you ask somebody to look and they're like, you're dumb. Like this is two arguments together. Sorry, personal experience. So convenience API, right? It allows you to do operations, and it also allows you to get information from the container, which is normally what you would use for connecting your application to it, right? You will get, for database, you will get credentials and JDBC URL. For Kafka, you would get your Bootstrap server's URL, right? And those you will pass to the application. And as you very correct, the idioms that you would be using are pretty boilerplate, because you would be, give me new Postgres, like say for Postgres, you get the library, you say new Postgres container, you say that container .start, and then you say that container get JDBC URL and return it and put it somewhere in a property map for the application to read. Kind of basic. For all these projects, this would be the same. So now, since some time, Spring Boot has the integration with test containers, and it's all automatic. You can expose test containers, primitive containers, as beans. So you can have a configuration file, and you would put it into tests, so it would be like a test configuration file. And you have an annotation for that. And you would just have the methods that return containers, and you would add bean on them. So they would become beans in the Spring context. And because Spring Boot knows about them, the life cycle is taken care of, right? There is a whole life cycle for beans, and the containers now are a part of that. So they will be started at the right time and stopped at the right time. And then, so your configuration still is in the method returning this bean, right? So there's usually just new Postgres container and the particular Docker image name or some additional things that you want to have. And then connecting to application to that, you have the service connection annotation. So you don't need to pass the actual particular properties to connect that type of technology, but Spring Boot takes it on itself. And then it works this way. When you have a service connection on the particular container for the type of the technology, Spring Boot will prefer that as the main source of that. If you put it on a database, that's the main database that will overwrite the Spring data source URL and username password. If it's Kafka, that's your main Kafka. If it's, I don't know, Elasticsearch, that's your main Elasticsearch. So it's not replacing like a ton of code, but it makes such a nice experience. You just have this slap some annotations, and then it works.
It's always that getting started experience, right? Like the less friction I have, the more I'm willing to like investigate and go further with something. When I have to like pull all this stuff down and like do all these 10 steps, like I'm not saying test container was that. I'm just saying when software is like that, I'm less inclined to go deeper. But if I can get up and running quickly and then kind of dive deeper later, it makes it so much easier.
No, absolutely.
Reducing friction. That's the big thing. Reducing friction. One of the things that I kind of, that the test containers has kind of opened the door to being able to actually validate our database migrations, schema migrations. I can do that. I can make changes. I can do this with data that I loaded as part of my test. It makes it easier. There's a lot of things that maybe kind of were more to the right. They were more ops related exercises, tasks, responsibilities. But now Test Containers has allowed us to do more of these things locally, validate them, and have that faster inner loop cycle than having the long feedback loop of doing the outer loop development.
We got a question here from Emmanuel. Do I have to have Docker running to run test containers?
Yes. So test containers requires a Docker environment to be present. That's where test containers by itself doesn't run containers. It sends commands to spin up containers, and then it matches the containers to the Java object instances or abstractions in your other language on the code side. So the containers are running in a Docker environment. That can be any compatible Docker environment. We do test on Docker Desktop and on the Docker engine on Linux. I've heard people having success and running them with other compatible Docker runtimes. So there's it. We implemented one of those at Atomic Jar, and now it's a part of a Docker portfolio called Test Containers Cloud. Right, so that Test Containers Desktop application pretends to be a Docker environment, but it doesn't actually spin containers by itself. Right, it proxies it to like a remote cloud isolated VM with Docker installed, and that runs containers. So you do have to have Docker. That's why it's also, I think it's so nice that Test Containers got into the Docker's family, because, well, it always depended on Docker as the runtime. And sometimes people ask also whether they can do, say, use Kubernetes as the runtime for the containers. And it's while it is a very good question, right? Showing understanding, but it's very hard to do. Kubernetes is very much like a declarative system where you configure and say, like, I would like things to be this way, and then they become that way eventually through configuration. There are no commands, and there are less flexibility for imperative things and creating networks and topologies of services compared to what we can achieve with the Docker environment.
So there's two questions that are now in my head. First of all, Emmanuel, thanks for the question. Do you not have access to Docker on your laptop? And then second of all, this idea of are there developers around that have access to Kubernetes on their laptop but don't have access to Docker? Is that a thing? Is that something that you've ran into? Because that seems weird. That's the question.
Yeah. Is that the question to Emmanuel or to me?
That's to you. Oleg.
Okay, I've seen all kinds of setups.
Yeah.
So very often this problem also becomes more pronounced, or not a problem, this challenge becomes more pronounced in certain CI systems, because that's the beauty of test containers, right? Everyone runs the tests the same. Mm-hmm. If your CI is a Kubernetes based, and it's very often, very often, sometimes it's a little bit awkward to expose a Docker service in a Kubernetes based CI system, and then you cannot run your tests there. which is very sad because there is no good way to overcome that. It's like, what do? You don't run the test at home or locally, or you just ignore your CI failures, or you ignore them there. So so the sort of the go-to default solution for that would be to maybe take a look at Testcontainers Cloud, because that's exactly what it will have you. Your agent can be running in the same pod or as a sidecar somehow in your local worker, CI worker, and then the containers that require the full Docker environment, when necessary, can be run in the cloud without kind of sort of fattening your worker by consuming more like resources for this project. Like, there are a bunch of scalability benefits from having on-demand solution. But so for Kubernetes-based CIs, that's one of the solutions. That's probably the easiest if you don't want to become your local Docker expert at work. But of course, you can sort of maybe run Docker, figure out how to run Docker in those CI systems, and then figure out how to run everything locally. And the same for local, right? Very often you don't want to run containers locally on your machine. Well, very often, sometimes, right? You cannot just allow yourself to run them other people's software locally, even though Docker Desktop actually comes with various security checks that you can configure, right? You can configure not being able to run random Docker images, right? You can prefer a certain set of what can be run, and you can run also hardened containers. So it's much more secure than it's running with the default set of privileges and security area, right? But still, sometimes you can just defer to the cloud.
So let me ask this quick question. I have these tasks over here that are running in a Docker CI, and I noticed that at some point I was using Testcontainers Cloud, and I don't recall, wasn't I able to connect to Testcontainers Cloud from within a Docker container without having to do the Docker and Docker stuff? Or am I taking a leap that's not there?
Yes. So like, if you're running already in container-based CI, say you're running in Docker containers, there are a number of options how you can do. You can do Docker in Docker. Mm-hmm. You can do Docker wormhole patterns and allow your containers to get access to your root Docker. You just say, like, this is my socket, and then it goes and connects there, which not maybe advisable, because if something happens, you take down your whole CI with you. But also you can run Testcontainers Cloud, because the binary for Testcontainers Cloud, this agent proxy, is the user space. You literally download, you run it. It doesn't need to do anything with your local network or containers, because it doesn't actually run containers locally. It just proxies to the internet service that you do. And there is even, if you're using OpenShift, for example, there is an ability to bring your own cluster, and there is a Testcontainers Cloud operator for OpenShift, so you can bring your own compute to that and have a more air gap, like a tighter, like, sort of system where you run things, if you prefer that.
That's good. That's excellent.
Cool. So I think we're at about time. I just want to close on a couple of things. One, I see, we talked about the Testcontainers Desktop. That's kind of something that's new. Anything else on the horizon? What's the team working on over at Testcontainers right now? Is anything coming down the pipeline? What are you guys doing right now?
So earlier this year, the team looked very hard on various AI use cases, and we added like a dozen modules in the vector databases space. So now, and
the PG vector, yep.
Yeah. There's a PG vector, there's VV8, there is Milvus, there is Quadrant, there is Chroma. There is like
Chroma too,
Neo4j,
yeah.
of course. There were a bunch, right? Every
Yeah.
database is the vector database nowadays. So we added a bunch of those. We added support for various Olama like container use cases and things, right? And then, well, in general, currently for the Java ecosystem, there is brewing also the next iteration of test containers, where we would change the API surface a little bit. The notable thing is currently there is a JUnit 4 annotation sticking out in the public API of test containers, and that brings the transitive dependency, and it kind of ruins people's time a little bit before they figure out how to avoid that. Even though technically it's just commanding your IDE never import from JUnit 4.
Right.
It should be easy, but it's not, and it's also a sore spot on people's eyes. It's not something that would, but it's a public API, so we cannot just like rip it off,
rip things out. Yeah.
So because it will break stuff for people. So
yeah, for sure.
There will be eventually a 2.0 release where we're gonna remove that. We're gonna change a little bit test container-based configuration API to allow reusing container definitions much easier. So you can have a single definition that run multiple containers off of that. It's gonna be neat and elegant and great. So there is stuff coming. It's not clear exactly when it will be released, but we are working on top of that. We are always adding more modules. If there are some technologies for which there are no modules, please come and create those with us, right? We are always accepting contributions. We can host them. You can host them in your repositories. We can add them to the catalog. There is a process. We would like to help you. If there is something that is missing, but you're using actually like in real life, right? And you would like to oh, I want that to be a little bit easier to other folks as well. That is an open source contribution that is not too demanding, as in like you're probably already running this, so you have the necessary expertise, and it might make the lives of people much easier. So yeah, those things are always a priority.
Cool. Where can folks get a hold of you if you want to be found? Some people don't want to be found, and I get that. But if you do, you are a developer advocate, so you're out there.
Yes.
Where can folks find you?
I live in Estonia. So it's not the easiest place to get to. But
I'm not encouraging people to go find you physically. I meant more like online.
little town called Tartu. It's a university. It's beautiful. It's very boring and small, but it's great. I love it here. So no, I go almost universally by @Šelajev, SHELAJEV. There's a link to my GitHub in somewhere in the chat, and that same thing goes to my socials, LinkedIn's, and even my YouTube channel, where I have a few short videos, 1 minute interviews with other folks that they find at conferences. So awesome. My Docker email doesn't have the H in the Šelajev, but it's oleg.selajv@docker.com. But you'll find, just Google Oleg Šelajev, and you will find the things, and you will.
And what's next
happy
for you?
To talk to you.
What's next for you, Wood? I know you're always on the conference tour. Where are you speaking next?
Interestingly enough, there's nothing this year.
That's good.
This year.
Same here. I'm clear for the year.
I've been on the road quite a bit last 2 months, and I got very tired of that. And then I'm very grateful that I spent several months at home. I think my next thing that I'm going to is JFocus in February.
Nice.
In 2025 in Stockholm, in Sweden. I'm very much looking forward to that. It's a wonderful conference.
All right. Well, you've got Oleg's details. You can find him. If you're in Estonia, please contact him first. Don't just show up at his house. Let's contact him, see if he wants coffee before you just drop by. All right. Oleg, thank you so much for taking time out of your day and talking about test containers with us. And I know you and DaShaun streamed for a while earlier, so thanks for taking so much time out of your day, and we really appreciate it.
Absolutely, my pleasure. I love talking about this, and especially to such a grateful community as the Spring ecosystem is fantastic. So
let's do it again soon.
Yeah, for sure.
Absolutely. Yeah.
All right. Thanks,
Thank you
Oleg.
very much.
Thanks, everyone, for joining. We'll see you next week.